These are the solutions for the study guide for the Chapter 10, Section 1, Chapter 10, Section 2 quiz. And so let's take a look at our first type of problem that we'll end up seeing. And here they're asking us to evaluate the expression. And so what we have to remember is when we have parentheses around the term that is being squared, or that is raised to a power, here the base is negative 1/8. And so if the base is negative 1/8, I'm going to multiply negative 1/8 the number of times the exponent tells me. And so in this case, I end up getting a positive 1 over 64. Two negatives make a positive. 8 times 8 is 64. Where in this case, I do not have the parentheses. So the base is not negative 6, it's positive 6. So the negative sign here means I'm taking the opposite of 6 to the 4th power. And so 6 to the 4th power represents 4 6's being multiplied together. And then I take the opposite of that answer. So it's going to be negative 1 times by 1,296 is what you get when you multiply 4 6's together. So that's going to be a negative 1,296. So on the next problem, we end up having to use order of operation. And so I'm going to bring down this negative 5, because there's nothing I can do with that. And then I'm going to do the exponents, because that's what order of operation says. It says to do the parentheses, then the exponents. And there were no parentheses, no grouping symbols, so I got to move to the exponents. Then I do multiplication, division from left to right. And lastly, I do the addition, subtraction from left to right. So I'm going to bring down the minus sign. 2 to the 5th makes 32. I'll bring down the division sign, and then 2 to the 4th ends up giving me 16. So now I'll go ahead and do the division here. 32 divided by 16 is 2. I'll bring down the minus sign, I'll bring down the negative 5, and then I'll add the opposite, and I have the same sign, so I add the two numbers, and I get negative 7 as the answer. Over here it says, in sphering, a person secured inside a small hollow sphere that is surrounded by a larger sphere. The space between the sphere is inflated with air. And we're supposed to find the volume inflated space. And so we're going to leave the answer in terms of pi. So we need to remember that a sphere's volume is 4/3 pi r cubed. And so we need the radius. And the radius here of the smaller one is going to end up being 1. So this is 1 meter. And the radius of the larger sphere is going to end up being 2 meters, because it's half of that diameter. And so what we're going to do is we're going to take away, we're going to subtract the large sphere from the small, we're going to subtract the small from the large sphere. And so the large sphere is going to have a volume of 4/3 pi times by 2 cubed. And then we're going to minus or subtract 4/3 pi times by 1 to the 3rd power. And so when I do this work, I end up getting 4/3 times by, and then 2 to the 3rd power makes 8, and then the pi, minus 4/3 pi here, because 1 times 1 times 1 just makes 1. So multiplying these numbers together gives me 32/3 pi, take away 4/3 pi. And since they're both in terms of pi, I can subtract the two numbers, and so I end up with 28/3 pi, and that would be the space left over. And since the space is in meters, I would say meters to the 3rd power. So in this next problem here, it says a new television program attracts 3 times as many viewers each week as the week before. There are 2 million people watch the premiere. The premiere means the starting point, the beginning. And so we start with 2 million people. We're asked to find how many watch the week after that, and then evaluate the expression to find the number of viewers 3 weeks after the premiere. So we're going to start with if there are 2 million people, how many people watch the week after that? So we have 2 million people, and so 2 million. And we're going to multiply that by, and then it attracts 3 times that number. And so 3 times that number, if I do just the next week, would end up being 3 times 2 makes 6, so I'd have 6 million viewers the next week. We'll say viewers there. So 6 million viewers the next week. Now let's take a look at the next part. It says how many watched the week after that. So we did that. Write and evaluate an expression to find the number of viewers 3 weeks after the premiere. So we're going to have 3, because it's 3 times each week, so it gets bigger by 3 times each week, raised to the number of weeks times by 2 million, the starting point. And so if I go ahead and figure out, or I'll say that W equals the number of weeks. And so that's an expression that I can use to evaluate this expression where they're finding out after 3 weeks how many people are going to be watching. So I'm going to take 3, raise it to the 3rd power, and then multiply by 2 million. And so when I do 3 to the 3rd power, that makes 27 multiplied by 2 million. And that value would end up giving me 54 million viewers. And so here is our expression that we used. Here was our initial answer and our final answer. Let's take a look at the next problem that we'll end up seeing. And here we are asked to evaluate or simplify this expression. And so we find that since we're multiplying, we have 8 m's, and then we have 9 m's. And the rule is that we're going to count up how many m's we have. And so in order to count up, we add, and that's what I'm going to do here. So we have m to the 17th power. Where in this other situation, we have groups. We have 2 groups of k to the 9th power is what we have. And so we are going to have k to the 9th times k to the 9th is what that represents. And so I'd end up adding the exponents in this representation, or I can think of it as, if I've got groups of numbers, I can multiply. So I could have done this, k to the 9th times by 2, because that's 2 groups of 9. 9 plus 9 makes 18. 2 times 9 makes 18. So k to the 18th power. Well, this one's very similar, except now we have a coefficient in front of the variable. And all parts get brought to this 3rd power. So this is the same thing as saying 5j to the 2nd times 5j to the 2nd times 5j to the 2nd. And so you can see how you've got 3 5's being multiplied. Well, the other way to do that is to use that rule of multiplication. Make sure you put an exponent of 1 and then distribute that 3 over both these terms. So it's 5 to the 3rd power, and then I have to raise j to the 2nd all to the 3rd power. And so this makes 125, 5 to the 3rd power does, and then j to the 2nd raised to the 3rd makes j to the 6th. Well, looking at this next one, we've got the same situation. We're going to bring all parts to the 3rd power. So we have 2 to the 3rd power, x to the 4th gets brought to that 3rd power also, and then we're going to multiply that by 3x to the 5th. So multiplying these numbers out, 2 to the 3rd power makes 8, and x to the 4th all raised to the 3rd makes x to the 12th power. And then we're going to multiply 3 times x to the 5th. So we multiply the 2 coefficients, that makes 24, and then we count up how many x's we have. We have 12 x's, and 5 x's makes 17 x's altogether. So 24 times by x to the 17th power. Well, this next one says a dodecagon is 5 to the 15th centimeters squared. Ed decides to expand the dodecagon by an area of 625 times the original size. Find the area of the new dodecagon. They want us to write it in exponential form. So we're going to take this 625 and we're going to rewrite that using exponents. And so I see that 625 is 5 times 5 times 5. I got that because I knew 625 was the product of 25 and 25, and 2 5's make 25, or 2 5's make 25, so 5 to the 4th power is what 625 is. Now it says we're going to make the area 625 times that size. So we're going to take that 625, which is 5 to the 4th, and we're going to multiply it by 5 to the 15th. And we have the same base now, so we can add the exponents up. So 4 plus 15 makes 19. So 5 to the 19th power centimeters squared. That's the area of the new dodecagon. So let's take a look at the last three problems here. This first one says a circular platter has an area of 169 pi centimeters squared. They want us to find the diameter of this button. And so I think we should have changed this word here to platter instead. But anyhow, I'll fix that later. So we see that the diameter is the distance all the way across. Well, I know the area formula involves radius. And so again, the diameter is the distance going all the way across, though. The area formula is pi r squared. And so I'm going to change the A to 169 pi. And because that's what the area is, it says, and then I have pi r squared. So when I go ahead and divide by pi, the pi's are going to cancel out, and I'm left with 169 equals r to the second power. Well, to solve this, I need to take the square root. Take the square root of both sides will eliminate the radical sign, and I'm left with, or the radical sign and the squared symbol, and I'm just left with r. And the square root of 169 is 13. So we have a radius of 13. To find the diameter, I'd have to double the radius. So 2 times 13 gives me 26. So 26 centimeters is the diameter of the platter. And taking a look at this one, it says that the baseball display case is in the shape of a cube. Find the edge length S and the surface area if the volume is 512 inches to the third power. So the volume for this is the length times the width times the height. Well, the length is S, the width is S, and the height is S. So I have the same variable raised to the third power will give me that volume. And so I know the volume is 512. And so it times by, or equals S to the third. So I'm going to take the cubic root this time. The cubic root of both sides. And so the cubic root of 512 is 8. So 8 inches, that's what the length of the side is. So this represents the side length. And from there, I can go ahead and find out what that surface area is. So the surface area is the area of one side, surface area of one side multiplied by the number of sides. So when we're dealing with a cube, if you notice we have a top, a bottom, we've got a right and a left, a front and a back, and that makes 6 sides altogether. And so I'm going to take 6 sides and multiply it by the area of one side. Well, the area of one side is 8 inches by 8 inches, and so that makes 64 inches squared times by 6. And so when I multiply those two numbers together, I end up with 384 inches to the second power. And that's going to be the surface area. So on this last one, we are just distributing the negative 3 over the addition here. So we have negative 3n minus 18 plus 10 equals negative 8. So subtracting these two numbers, because they're opposite in sign, leaves me with negative 8 equals negative 8. And I go ahead and add the 8 to both sides, and that makes 0. Now in this situation, when I divide by negative 3 does go into 0 times. So that tells us that n equals 0. We can check the work by substituting our answer in. So negative 3, 0 plus 6 goes inside the parentheses, plus the 10 equals negative 8. Let's see if it works. This makes negative 3, and then we have 0 and 6 make 6. And when I go ahead and multiply, I get negative 18. Negative 18 and 10 add to make negative 8. Negative 8 does equal negative 8, so yes, it's true. So that is the solutions. Those are the solutions to this study guide. Good luck.